Hello everyone, today we are going to prove that the sum of an arithmetic series with the odd number of terms equals the product of the middle term of that arithmetic series and the number of terms. So when we are solving problems involving arithmetic series or geometric series, it is always a good idea to use variables to represent the first term of that series, is common difference or common ratio, depending whether the series is arithmetic or geometric, and as well as the number of terms. So in this case, we want to have a variable which represents the first term of the arithmetic series. So let the first term, so we're going to let the first term, so first term of that arithmetic series will be A. And because this is an arithmetic series, we will be using a variable to represent the common difference of that series, not common ratio. Common ratio is for geometric series, but common difference is for arithmetic series. So what will be the common difference of an arithmetic series? Well, conventionally, we use the variable d. So we're going to use common difference. I'll write it here. Common and the number of terms. So there's a special constraint on the number of terms of that series, and the constraint is that it must be odd. Therefore, we cannot use any variable to represent the number of terms it has, because that variable can represent any number, and this is just not the case right here. So we're going to let the number of terms So the number of terms will be odd. And conventionally, we use 2n minus 1 or 2n plus 1, like those things to represent odd numbers. In this case, we'll use 2n minus 1. However, it doesn't really matter what we use. We can use like 2n minus 3 or 2n minus 1. The only difference is that the possible values of n in this case will change, because we notice that the number of terms must be positive. In this case, we are referring to positive integers n. But if it were 2n plus 1, notice that n equals 0 will be a possibility. So these are our variables. We got the variables down. Now, this is in words. Whenever we have a word problem, we always like to turn it into math equations. So now what we're going to do is that we're going to turn words into math. All right, so the first term will be a. The second term, because the common difference is d, it will be a plus d, and so on until the last term. In the last term, so we're essentially proving that. So on one side it will be a. This is the second term, a plus d, and so on. The last term will be a plus 2n minus 2 times d. And this is because in order to get from the first term to 2n minus 1 term, what do we do exactly in an arithmetic series? Well, we add the common difference d exactly 2n minus 2 times. And if you want to really verify that we got the number of terms right, notice that this is a plus 0d, this is a plus 1d, and so on to a plus 2n minus 2d. So this is basically like 0, 1, all the way to 2n minus 2. And if we count the number of terms that has, that is 2n minus 1. So this is an easy way to check whether we have made a mistake or not. And in this case, everything seems good. All right, we got one side down. Now we want to do the same for the other side. So now our task is to find the middle term. So what exactly is the middle term? So the middle term, you know, is going to be a. However, there will be a common difference that we have to find. So for clarity, this is a plus 0d. So right here will be 0. This will be 1, all the way to 2n minus 2. And our task right now is to find the middle of 0, 1 to 2n minus 2. And a quick way to do this is to add 0 and 2n minus 2, and then divide by 2 to get a final answer of n minus 1. But if you want a better way to check this, we notice that we just count the number of numbers here. We notice that there's n minus 1 numbers on this side, and there's also n minus 1 numbers on this side, so therefore we have confirmed that n minus 1 is indeed the middle number of this arithmetic series. So here we go. Yeah, we call that the number of terms as 2n minus 1. Alright, so we got everything down right now. And if we want to prove that these are equal, we have to prove, to show that this side, the left side, equals the right side. So this side is hard to deal with. So you may ask yourself, how can I simplify that? Well, this is our arithmetic series, and it may remind you guys of Gauss's formula. And this goes like this. So we basically notice that a plus 2n minus d. So if we pair these up, and then we pair these up, well, the sum of these two are always the same. And precisely, this will be a plus a plus 2n minus 2d. And how many of these quantities do we have? Well, originally we had 2n minus 1 terms. However, because we pair these up, then we have to divide by 2 on this side. And this side will remain unchanged. We can further simplify the left side, so this will be 2a plus 2n minus 2 d times d times 2n minus 1 over 2. And as a last step, we can divide this by 2. So now we have a plus n minus 1 times d times 2n minus 1 equals this. Therefore, left side equals right side, and we are done. And this will finish our proof of why the sum of an arithmetic sequence with odd number of terms equals the product of the middle term and the number of terms. Thank you very much, guys, for listening.